Example 5. Two circles intersect at 2 points A and B. AD and AC are diameters to the two circles. Prove that B lies on the line segment BC. What is given here is AD is the diameter of the circle and AC is the diameter of the circle. And what we have to prove is D lies on BC. That means what we have to prove is the angle made here is 180 degree. If it is 180 degree, we can say B lies on DC. So what is given here is AD and AC are diameters. So if AD is a diameter, what about the angle DBA? What about the angle DBA? It is 90 degree because angle in a semicircle. So this angle is made by this chord AD. That means AD is the diameter. So what we can say is angle ABD is equal to 90 degree. Same way AC is the diameter. So angle ABC is the angle made by this diameter AC, which is again is equal to 90 degree. That means angle in a semicircle is 90 degree. So if these two are 90 means the sum is 180. That means B lies on DC. We can write one by one. Angle DBA or angle ABD is equal to 90 degree. Bracket you can write angle in a semicircle. Same way angle ABC. Angle ABC is again equal to 90 degree. Same reason, angle in a semicircle. So what about angle ABD plus angle ABC, which is equal to 90 plus 90, which is equal to 180 degree. That means DBC is a straight line. This means that B lies on DC. This implies that BDC is a straight line and B lies on DC. This is not BDC, it is DBC. DBC is a straight line, that means B lies on DC. Then example 6. Prove that the quadrilateral formed by the internal angle bisectors of any quadrilateral is cyclic. Prove that the quadrilateral formed by the internal angle bisectors is formed by the internal angle bisectors of any quadrilateral is cyclic. What do you mean by cyclic? The four vertices lies on a circle. So what are the properties which you have learned? Cyclic, the sum of either pair of opposite angle is 180 degree. If a quadrilateral is cyclic, the sum of either pair of opposite angles is 180 degree. If any pair or any one of this is sum is 180, we can say it is cyclic. So what we have to prove here? We have to prove that it is cyclic. For proving that, what we have to prove is at least one pair of sum of opposite angles is 180 degree. So we have to either you can prove angle E and angle F, sum of these to 180 degree, or you can prove angle F plus angle H is 180 degree. So here what we have considered is, actually what we need is the internal angle bisectors of a quadrilateral. So we have to consider a quadrilateral ABCD in which AH is the angle bisector of A, BF is the angle bisector of B, CF is the angle bisector of F, angle bisector of C, DH is the angle bisector of D. So, these forms a quadrilateral EFGH. What you have to prove is EFGH is cyclic. To prove EFGH is cyclic, for that what do you have to prove? At least one pair of sum of opposite sides is 180 degree. One pair of sum of opposite sides is 180 degree. Opposite angle is 180 degree. So, what we are going to consider here is, we are going to take the sum of these two. Take the sum of these two. For that, if we consider this angle FEH, angle FEH is equal to this angle, isn't it? So, what we can write is angle FEH. FEH is equal to angle AEB. Angle AEB using vertically opposite angles. So, what I said is, these two angles are equal using vertically opposite angles. So, what about this angle actually? Consider this triangle ABE. Consider this triangle ABE. What about this angle? Using angle sum property. This is actually half of A, this is actually half of B, because it is all these are angle bisectors. So, how will you get this? Angle AEB. Angle AEB is equal to 180 minus this angle plus this angle. So, I am going to write, which is equal to 180 minus, what about this angle? Half of angle A. This is half of angle B, which is equal to half of angle A plus half of angle B. I will explain this once again. Actually, we need this angle FEH, which is equal to this using vertically opposite angles. This angle we can find using angle sum property, 180 minus this angle plus this angle. But this angle is half of A because A is the angle bisector, and this is half of B using angle bisector. So, what we can write is 180 minus half of angle A plus half of angle B. Similarly, we can write this also. This angle is equal to this angle, that means FGH, angle FGH is equal to angle DGC because vertically opposite angles. Using the same step we can write this angle is equal to 180 minus of this angle plus this angle. But this angle is half of angle D and this is half of angle C. So, we can write this as angle FGH. Angle FGH is equal to angle DGC, which is equal to 180 minus, half of angle D plus half of angle C. So, we can write this as, we are not expanding that. What we need actually, we need to prove that this triangle, this quadrilateral EFGH is cyclic. For that we are going to prove this angle plus this angle is equal to 180 degree. So, we want to add these two. Add these two. Angle FEH plus angle FGH is equal to 180 minus half of angle A plus half of angle B, then plus 180 minus half of angle A plus half of angle B. We are adding these two. So this is equal to, so 180, 2 times 180, so 180 plus 180, then minus half I am taking out, and angle A plus angle B plus angle C plus angle D. 180 plus 180 minus, I have taken half, minus half out and the remaining. Then what about angle A plus angle B plus angle C plus angle D? This is a quadrilateral. ABC is a quadrilateral. So what about the sum of angle sum property? The sum of all the angles is 360 degree. So we have to replace this angle A plus angle B plus angle C plus angle D by 360. So we are getting it as 180 plus 180 minus half of 360, which is equal to 180 plus 180. What is half of 360? 180 itself. So we can cancel these two, remaining 180 degree. So what is the conclusion? Therefore, EFGH is cyclic. What is the reason? What's the reason? Sum of opposite angles 180 degree. So we have, what we have done is we have considered a quadrilateral ABCD and we have drawn the angle bisectors and we got the quadrilateral EFGH. Its naming is not EFGH, it is EHGF. It is EHGF. EHGF. And what we proved is sum of opposite angle 180 degree. Then exercise 10.5, first question. If A, B, C are 3 points on a circle with center O such that angle ABOC is 30 degree, AOB is 60 degree, and if D is a point on the circle other than the arc ABC, find angle ADC. What is given is this angle BOC is 30 degree, AOB is 60 degree. What we have to find? We have to find angle ADC. Can you find? So what is this is the arc actually. This is the arc, and angle made this arc at any point D on the circle is angle ADC. What about angle AOC? Is the angle made by the same arc at the center. So what is the connection? Angle made by an arc at the center is double the angle made by it at any other point on the remaining part of the circle, isn't it? So what we have got is, this is an angle made by the arc at the center and this is the angle made by the same arc at the point D on the circle. So this fully we need, actually this is the half of this. So that is what we are going to write. Angle AOC is equal to 60 plus 30, 90 degree. Therefore, angle ADC is equal to half of 90, which is equal to 45 degree. What's the reason? Angle made by an arc at the center is double. Angle made by an arc at the center is double. So the answer is 45 degree.